let's now try to look at the limits involving infinity. So we have for algebraic functions a little bit of theorem and properties. So we need to remember, again, these properties. So the limit as x approaches positive or negative infinity for this function here, 1 over x to the power of n, as long as n is a positive integer, is just 0. Okay, so meaning if we have, for example, limit of let's say x, as x approaches positive infinity, say we have 2 over x to the power of 3, okay, x to the power of 3, we simply say this is 0. Okay, so why 0? Because this is actually 2 times 1 over x to the power of 3, and we know that 1 over x to the power of 3 as x approaches infinity is just 0. So 0 times 2 is just 0. So again, you need to remember that for 1 over x to the power of a number, as x approaches infinity, it is 0. Next, we have this theorem. So what if it's the other way around? It's not infinity. X is approaching 0. So we have two possible scenarios. Either the power is 2n is even. Okay, either the power is even or the power is odd. Okay, again, this is for x approaching 0. So if it's even, it's positive infinity. If it's odd, it's positive and negative infinity, or we simply answer the NE because the values are fluctuating. We don't know where is it going. Okay, so for example, so you're asked to find the limit of 1, or let's say 3 over x to the power of 4 as x approaches, let's say 0. Okay, so since 4 is even, we simply say this is positive infinity. Okay, so we don't need to solve it anymore. Just remember. Okay, so again, number 1, x approaches positive or negative infinity, 1 over x to the power of n, it's just 0. Number 2, x approaching 0, if it's even, the power is even, it's positive infinity. For number 3, x approaching 0 again, if the power is odd, it's DNE, does not exist. Let's have example number 3. We are asked to evaluate the limit of 3x cubed plus x squared minus 2x plus 1 all over x cubed plus 2x minus 3. Okay, let's go to the board. Okay, so again, let's try to evaluate. So using substitution rule, so we know that 3 times x cubed is just, remember that this x is approaching positive infinity, so we are sure this is positive infinity. Okay, so regardless of the value here, we are sure that the biggest value at the numerator is positive infinity. We have infinity, and the biggest value at the denominator is also positive infinity. Okay, so we have infinity over infinity, and if this happens, again, if this happens, infinity over infinity, this is an indeterminate form. This is not yet the answer. Again, this is not yet the answer. Okay, so let's try to solve using our theorems. Okay, so how? So let's try to rewrite first. 3x cubed plus x squared minus 2x plus 1 all over x cubed plus 2x minus 3. Okay, so the genius of the theorem, okay, so it actually helps us not to use factoring, but rather we can actually try to multiply a factor which will simplify our expression. Okay, so how? We simply multiply 1 over x to the power of n. Okay, x to the power of n. I just write n first. 1 over x to the power of n. Okay, so of course we're not going to multiply x to the power 1 over to the x 1 over to the x 1 over x to the power of n, but instead we are going to multiply the n here will be the highest degree or the highest exponent in the scenario, that is 3. Okay, so we're going to change n to 3. Okay, so I'll write 3 here, x to the power of 3. Okay, so what will happen if you multiply 1 over x to the power of 3? Okay, so let's try to multiply first. Okay, so what will happen if you multiply this one here? Okay, so this becomes 3x cubed. Okay, 3x cubed over x cubed. Okay, next multiply it here. Okay, to the x in x squared. We have plus x squared over x cubed. Okay, then we multiply to negative 2x. So we have negative 2x over x cubed plus, we multiply to the last term, 1 over x cubed all over. Okay, so let's try to move all over. Okay. Okay, so wait first, I forgot to write limit of x, limit as x approaches positive infinity, and this is also limit of x as positive infinity. Okay, now for the denominator, same process. We multiply or we distribute the factor 1 over x to the power of 3. So we have here, so we have now x over 3, x to the power of 3 over x to the power of 3. Then we have the next plus 2x over x to the power of 3, and lastly we have minus 3 over x cubed. Okay, so observe. So now we need to simplify. So x to the power of 3 over x to the power of 3, this is just cancel out, so we are left with 3. Now about this, x squared over x cubed, of course this becomes 1, while this becomes, the exponent of this becomes 1, so we will have 1 over x. Okay, and of course for 2 over x to the power of 3, this becomes squared. Okay, then let's just leave 1 over x cubed alone. Here this becomes 1. Okay, then here cancel out x, this becomes x squared, and let's just leave negative 3 over x cubed. Okay, so let's continue below. So let's try to rewrite to make things clear. Let's try to rewrite. So we have limit as x approaches positive infinity, so this becomes 3. Okay, so this here becomes 3 plus 1 over x plus, sorry, not plus but minus minus 2 over x squared plus 1 over x cubed. Okay, all over. Okay, so all over. So x cubed over x cubed is just 1 minus 2 over x squared minus 3 over x cubed. Okay, are you keeping up? Okay, so now we can try to substitute our infinity. Okay, so of course 3 here is just 3, but if we have 1 over x, if you try to remember our theorem, the limit of 1 over x as x approaches infinity is correct. This is 0. This becomes 0. Okay, same goes for negative 2 over x squared. because it's x to the power of n. This is 0, and this is also 0. Okay, so here we have 1, the denominator, this is 0, 2 over x squared is 0, and 3 over x cubed is also 0. So this will give us 3 plus 0 minus 0 plus 0 all over 1 minus 0 minus 0. Again, this is 0 because of the theorem. We have 1 over x to the power of n. And remember, if you have a constant 2, this is just times 2. Okay? So, at the end of the day, this is just 0. Okay? So, this can be simplified into 3 over 1, which is 3. Okay? Hence, our answer is 3.